Hi there, this is Dr. Embody with Project 6. Now this is about functions. And functions let us use this notion of divide and conquer, decomposition of the problem. Break it down into small pieces. I mean, if I just gave you this problem and said, here, solve it, one of the first things you'd have to do is break it down into smaller, easier to solve pieces. And that's what we've done in this project, is we've specified functions and say, do each one of these, do them one at a time, and this will give you, this will help you solve this problem easier because do these functions one at a time. Develop each function, test it, and then move on. The other thing that's important in this project is, so this is kind of a little number theory type of project. It's just a number puzzle to solve. When I was a math major, I kind of liked number theory and that kind of thing. And so how do you go and solve this kind of problem? Well, you want to use what we call brute force. That is, try all the possibilities. So one of the common mistakes I find new programmers is that they will try to overthink the problem. Oh, how do I try to be clever about that? And often the answer is no, just try all the possibilities. And so keep that in mind when you're working on this project. Take the easy way. Oh, let's just try all the possibilities and then select out the ones that match what the particular criteria are in. And we saw that before when we found did the word puzzles. So, find the word that has all of the vowels A, E, I, O, U. Well, what do? We go through the whole list of words and try each one. And we're going to do the same type of thing here. And that, by the way, because the numbers are relatively big, makes this program run slowly. All right, so let's take a look at this. So what are we doing here? Well, we have a number puzzle, and we have these things called transposable integers, and what that means is that they have been rotated, but they're rotated in a very special way. We multiply by some number, and it just happens that the product is a rotation of the original number. So for example, we can see here in this first one, we have this number 128205. We're going to multiply it by 4, and it's the same result as if we had just taken that 5 and rotated it around to the beginning. Right. How do we do that? Well, we try a whole bunch of possibilities, and if that characteristic happens to be true, then we label it as a transposable number and print it out. And we can see that here. So like on this last one, we took this particular number, multiplied it by 4, and it turns out that it was the same as if we had taken the 76 and rotated it around and stuck it at the beginning. So that's what we're going to do. We're going to look at rotations of numbers. So we're going to multiply. We're going to go through, try every number and multiply it by every single digit integer and see if the result happens to be a rotation. All right, and it may be a rotation of 1, like we saw that. It may be a rotation of 2 or 3 or 4, any number. Right, up to the length that we have here. And there's a couple of things to make this interesting. It may be that the leading number is 0, so we have to handle that. But again, we're going to go and try all the possibilities. And just to make this interesting, we're going to get a range of values. We're going to get that out of a file. Yeah, you've done that kind of thing before. That's just a little practice with functions and that. Let's take a look. So we require you in this project to have a certain number of functions. And they have to have these names exactly, and they have to take those arguments, and then we give you a specification for each of these. And the way to go about this is to take this first one, forget about everything else. Just take this first one, write that function, check it out, get it working. Okay? It's like, all right, now we got that one going. Let's go, and now we know I can take any string and rotate it. Then we can go and look at this this next one, which takes two strings and says, oh, is one a rotation of the other? And so what do? We try all the possibilities. Remember I said about brute force. Take all the possibilities, try them all. Take one of these, rotate it once, did it match? Rotate it twice, did it match? Rotate it 3 times, did it match? And keep doing that, and if it ever matches, we return true. Notice it doesn't say we have to find multiple ones. If it ever happens, return true. Otherwise, return false. And like I say, use the rotate function. So now I can check and I can test that out. Test it out. Make sure it's working right. And so on. You work your way down. Next thing we say, all right, I will. Is it possible to multiply a number and find out that that the product is some rotation? And so what do? We take that number and we try all the possibilities. Multiplying it by 2 to 9. It's not very interesting to multiply it by 1. And again, so we're trying all the possibilities, which tries all the possibilities, which and so on, right? And so if it's transposable, at this point we will print it. Okay, we'll print the number, the multiplier, and so on. Now, there is this weirdness here in that we also check that number with a leading 0. This is done as a separate function, so you got and that's because these are numbers; these are not strings. And so now you want to tack a 0 onto the beginning of that number before you go to check whether it's transposable and so on. So you can see this conversion here from numbers in these functions, we're going to call strings in those functions. So that'll be just part of your function. It's not very hard to convert a number to a string. If you haven't done it before, you can just take the string of the number. Right, and now try that out. Try that out in the shell, and we work our way through each of these functions, making sure that it works. Which values work? Well, you can grab a number out of the output to check with that. Okay. So. All right, and then we can move through these, open a file, you've done that before, and then we process the file, and we open it, we get the start and end values, and then we try all the possibilities, try it, brute force, try them all. And at the end, there's our file that we give you has values from 20,000 to 500,000. So it takes a while to go through each of those because each of those you have to try many things and then print them out. So these are the results you should get with that file. Now we may give you, we will give you different files to test with. They'll probably be subsets of this because that's where the more interesting numbers are. Let's start here with rotate. Now, what do I do with a all right, I take rotate, it takes some string, and then we create a new string, which is a rotation of the old string. Right now I'm just going to say it equals s, and then we're going to return that. Obviously this doesn't do what we want to do. You need to put something in here that actually rotates it. Slicing is your friend. These are strings. Just use some very simple slicing to do that. Also notice that we need to have something here, a statement, rotate s 1 to the right. Okay, so what do we this returns a rotation of s something like that. So we need to have a doc string in there that's a part of our requirements, describes what's going on in the function. And I can save this for right now. I'll just call it my dummy file. And of course, I can now test this. I can rotate a string, 1, 2, 3, 4, 5, and of course, it doesn't really rotate it because we haven't put that in there. That's part of your job. But notice how I can just create this one function and test it. Okay, so I've skipped past waiting the many minutes for this program to run, and by the way, it takes almost as long to get that last number as it does to get all the other numbers. So you'll watch you'll watch this thing run very slowly because we're trying all the possibilities, and that last one takes a while. So have some patience there. All right, now let's take a look at what we have to work with. So I actually have here my real rotate, and so if I give it a string, it rotates it. I can set a string, and I can say rotate that string. Okay, I can grab that value, and so we've saved it. But notice that S, the original, hasn't changed. So we have a rotation of that. We returned it, but it doesn't change the original. That's by the way we designed that function. I can put this in a loop. Remember, if we want to try all the possibilities. And one way to do that is to go through every part of the string, and I can print a rotation of S. And notice what happens. Well, I keep rotating S, but it's rotating the original one, so I don't make any progress with that. How can I improve on that? Well, one thing I can do is say something like that. Every time I go through, I rotate the S and I grab that as the new one. Right? And when I look at that, we see that now I've gone through and I have every single one of the rotations that I have, and it starts with the first one and it goes through with all of the others. And in that case, I changed every time. So that turns out to be useful as I go through and do the other functions. So let's assume now that I have my rotation function working, and I've tested it out. So my rotation function is working, and it works fine. And oh, by the way, there's nothing with my rotation function that says that it has anything to do with numbers, right? It works with any string, right? But that's not really that important for us because, well, it works with any string, but also happens to work with a string of numbers. What does the next one say? The next one says, oh, if I have two strings, is one a transpose of the other? So let's try that out. And this takes two strings. So let's give it ones that are a rotation. And we would expect that to come out with true. How did we solve that problem? Well, we tried every possible rotation of one and checked to see if it matched the other. And I could, for example, just to make sure that this also will give me a false, that went through and tried all the possibilities, said no, it's not a transpose of the other. Remember, take the simple approach. Try every possibility keep rotating it by 1, and if it matches, great, we got it. If not, all right, then we don't. And you work your way through these functions one at a time like that. Each one gets tested. So we write the rotate string, we test it, boom, it's working. All right, we do the same. Now we use the transpose, which calls the rotate function, test it out. Now that one works, and we can keep working through these. How about the get transposability? So what does this mean? This means we take a number and we multiply it by one of these integers, 2 to 9, because 1 isn't very interesting. And again, we're going to do this brute force. We're going to try every possibility and see if we in fact get a transpose, and we call our transpose function, which repeatedly calls the rotate function. Right? So that's why we could build these up. Make sure that you get these working. Now it's pretty easy because we just have to say, oh, try this, and then we just check to see whether it's transposed. Brute force, try them all, check each one to see if it's transposed. And we can look down, what numbers might I test with this, and we can go down and grab a number out of here. Let's take one that doesn't have its leading zeros. So we'll test this one just because it gives us something to work with. So once I think I have this function working, we can test it out. So this says we're going to get the transposability of some number. Notice this is going in as a number. So the number that I was looking at there was 102,564. Now it's going to go through and it's going to try and multiply that by 2, by 3, by 4, and so on. And when it finds a result, it prints it out. So it found that when it took the number and it multiplied by 4, remember it was trying all the possibilities, it came up with, oh, this product is a rotation of the original number, so it prints it out. Now we also have, because these are taking numbers and we have the possibility of numbers, the rules here include numbers that start with 0, such as this guy here. All right. So we have to check a number that starts with 0. So because we're dealing with ints and leading zeros don't work, we create a separate function that takes as the input this number, creates a string, puts a 0 on the 0 digit on the beginning of that, and then it works just like the other transposability function. So I can say get transposability 0. And this will add a 0 onto there. So we can take the number and it's going to tack a 0 on there, and we find out with the 0 tacked on there and we multiply it by 9, we get something that is transposed. So we go through with each of these functions are nearly identical. In fact, you can call one from the other if you want. No, I guess probably you can't because of the 0. But in any case, you just go through, you try all the possibilities, keep calling the transpose function, and so on. And then, now we can find the transposability of them. We can open a file and then process a file. Now, in fact, opening a file, if you wanted to, it's often good let's see, opening a file took no arguments, right? Takes no arguments. We could, for testing purposes, let's put a doc string in here. So I'm doing one that doesn't meet the specs, but I can just say open range.text, and I can go back and I'm going to return that function pointer. File pointer. Now, of course, this doesn't meet the specifications, but it actually, this will work while I'm testing the program, and we can go ahead and do that, and then write the rest of the program, and then come back later and say, all right, now I got these specifications, and I have to do something if the incorrect file is entered, and have to take a file name as an input, and so on. All right. So build this thing in pieces. That's critical. You will find your TAs and myself, if you're asking questions, if you try to write this whole thing and don't test the individual pieces, we're going to be mad at you because you're not doing this the way we said. Build it up a little bit at a time. We've done the job of decomposing this for you, and in future projects you're going to do that decomposition. We're not going to give that to you, but on this particular one we did. All right, good luck.